Okay, so this is our first actual lesson into theoretical probability, and this is just your general probability. So a sample space has equally likely outcomes. If they have equally likely, then there's a 1 out of n chance. So think of it as if you flip a coin, it's equally likely to get a head. As a tail, that would be 1/2. If you roll the dice, 6, each, it's equally likely to fall onto one of the sides, so that'd be a 1 out of 6. So if there's however many outcomes there are, n outcomes, then it's 1 out of that outcome. So then when we're looking at the probability of the event A, it corresponds to the number of outcomes of A over the total number in the sample space. Now, one thing I'll point out to you, this n just means number. This notation is important to recognize because sometimes they'll just ask you what is this value, and so you have to recognize it just wants what is the number in that event, or what is the number in the universe. Okay, so a ticket is randomly selected from a basket containing 3 green, 4 yellow, and 5 blue. So the first thing you want to consider, what is the total number of outcomes? We have 3 plus 4 plus 5. So the total, the number in our universe is 12. All right, so for letter A, it's also very important that you label what it is you're finding. Okay, sometimes as you guys are doing your IB test, you don't always have it very clear what your answers are going with which one. So you want to label this answer as the probability of green. So then the number of green, the number in event A, green, is 3 out of the number in the universe, 12. And I'm just going to reduce it. Typically, you'll leave it just as a fraction like this. I would say this would probably be like a non-calculator question, so you would just leave it as a fraction. A decimal, you could do 2. Because they'd be equivalent either or, I think it's just easier to leave it as a decimal or a fraction. Letter B, green or yellow. Green or yellow. Or means we're going to add our green and yellow together, because that would be our total success out of our total 12. So 7 out of 12. Orange. Probability you're going to get an orange if there are no orange there is 0 out of 12, which is 0. Remember, all probabilities should be between 0 and 1. So probability of green, yellow, or blue, those are all of our tickets. So that's 12 out of 12, which is 1. Okay, so an ordinary 6-sided die is rolled once. So that means in our universe, the number in the universe is 6 because there are 6 sides. And I don't know if it would help if you list the universe, because then we're just choosing out of the universe. So the probability of a 6, we have 1 out of 6. I don't know why I put that equals there. Letter B, not getting a 6. So I'm going to go not 6. So which ones are not 6s? We have 1, 2, 3, 4, 5. out of the 6 means we're not going to have a 6. Probability of a 1 or a 2. There's 2 of those. 2 out of 6 can reduce down to 1/3. Not getting, so not 1, not 2. There's 4 of those, and 4 out of 6 can reduce to 2/3. So let's remember, first of all, 6 and not 6, these are called complementary events. A and A prime, these are complementary. And in general, complementary events, the probability of complementary events always add up to 1. So 1/6, 5/6 is 1. 1/3, 2/3 is 1. So sometimes it's actually easier to figure out 1 minus the complement than it is to figure out the whole thing. All right, so this wants us to use a 2-dimensional grid to find the sample space for tossing a coin and rolling a die. All right, so I'm going to go like this. 1, 2, 3, 4, 5, 6. Then we have heads and tails. So this is head 1, head 2, and we also have tail 1, tail 2, okay, so now that we have all of our sample space right in front of us, A said, what is the probability of a head? So first of all, the total, the number in the universe is 12, and the number of heads is 6 out of 12, or 1/2. B, the key word for B, tail and 5. Well, there's only one that's a tail and a 5 in our sample space. Or when it's or, that means we're going to add. So we take all of our tails, 1, 2, 3, 4, 5, 6, plus any other 5s is 7 out of our total 12. All right. Display the results when 2 dice are rolled and the scores are added together. All right, this one's a little annoying. So we're going to put 6 along the bottom, 6 along the top, or going up. And then the middle is the sum of each of them. So 1 and 1 is 2, 2 and 1, 3 and 1. Then I'm going to take 1 and 2, 2 and 2, 3 and 2. All right, so we have a 6 by 6 amount. So the total, the number in our universe here is 36. And we want the sum is 7. So I'm just going to highlight 1, 2, 3, 4, 5, 6. So probability of a 7 is 6 out of 36, which is reducing down to 1/6. Okay, so this one we have to read our Venn diagram. Notice this, the universal set U is the number of kids in a class. Each dot is a student. The event B means the student has blue eyes. So that means everybody in B has blue eyes. Everyone that is not in B does not have blue eyes. So probability of blue. All right, so first of all, let me do what's the number in our universe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 19, 19, 20, 1, 2, 3. 23 total in our universe. And then there's 8 blue out of 23. And not blue, I can always just use my prime. So this is just interpreting the Venn diagram. All right, so we have 30 students in a class, 19 are studying physics, 17 are studying chemistry, and 15 study both. So the first thing we're going to do is do a Venn diagram to organize our information. I'm going to tell you, a lot of times you've got to come up with the Venn diagram to organize it yourself. So that's something that's important. So we have our universe. I have 2 events, physics and chemistry, and some study both. So that means these overlap. And I have to label, this is my physics, this is my chemistry. 15 study both, so that's your overlap. That's what's in both my physics circle and in my chemistry circle. So anytime you see the word both, it goes in the middle. That's your overlap. Now, here's where you have to be very careful. 19 study physics all together. Well, if I cover up my chemistry, in my physics circle, I already have 15. So I need to put 4 on the outside of the chemistry circle that's still in the physics. My total for physics is 19. Now there's 17 in chemistry, but I already have 15 in my circle. So I have another 2 to get up to my 17. Now, how many students am I up to so far? 4 plus 15 is 19. There's 21 in my physics and chemistry, but there's a total of 30 students altogether. This is really important. These have to add up to 30 altogether. That means there's 9 in the universe that are not studying physics or chemistry. Now, typically, if this is an IB question, each number placed is worth a point. So this really is important that you're counting that. Okay, so this is letter A. And then letter B, probability of both is 15 out of 30, because both is the overlap, which is 1/2. Probability of at least 1. All right, so that means somewhere in this circle, which is our 21 out of 30. And then I can reduce by 3 to get 7/10. physics, but not chemistry. All right, I'm going to show you some notation here. Probability of physics and not chemistry. This means and or intersect. They're in physics, but they're not in chemistry. All right, so which ones are taking physics, but not chemistry? 4 out of 30, and that reduces to 2 out of 15. Exactly 1, so not both. So there's 4 plus 2. So that's 6 out of 30. And neither is 9 out of 30. And simplify by 3, 3/10. And I think that's it.